on time, as traditionally understood, is often seen as a linear progression from past to present to future. However, in the context of the Genesis framework, a model that aims to bridge the gap between physics and higher dimensional theories, time is redefined not as a real dimension, but as a measure of the speed at which gravity processes entropic information in three-dimensional space. This video explores this innovative perspective, explaining how time can be understood as a coordinate within a complex entropic system rather than as a standalone dimension. By rethinking time's role, we can gain deeper insights into the fundamental workings of the universe and the computational memory embedded within its structure. In the Genesis framework, time is conceptualized as the rate at which gravitational forces process the entropic states of matter and energy. Unlike the traditional view where time is seen as a constant flow, here it is variable, contingent upon the entropic interactions occurring within a given system. This approach aligns with the notion that time's passage is intrinsically linked to the dynamics of entropy, particularly how information is encoded, stored, and transformed within the fabric of space-time. Gravity, in this framework, is not merely a force, but a mechanism for encoding and retrieving information from the quantum to cosmic scales. As such, time becomes a functional parameter that denotes the speed of these entropic computations rather than an absolute dimension through which events inevitably progress. Redefining time as a measure of entropic processing has profound implications for both theoretical physics and practical cosmology. It suggests that the flow of time may differ across various parts of the universe, influenced by the density of gravitational interactions and the rate of entropy change. This perspective can help explain why time seems to move at different rates under varying gravitational conditions, a phenomenon predicted by general relativity, but further nuanced here by the entropic characteristics of space. Additionally, this model posits that what we perceive as the past, present, and future are merely different states of entropic information processing within a higher dimensional space. This not only challenges our conventional understanding of temporal sequence, but also opens new avenues for thinking about causality, free will, and the preconditions of existence. Time, entropy, and quantum mechanics. Linking time directly to entropy processing also bridges some gaps between classical physics and quantum mechanics. In quantum realms, where particles exist in superposition, time is often treated as a background parameter rather than an active variable. By viewing time as dependent on entropic processes, we can conceptualize quantum superpositions not just as probabilistic states, but as instances where entropic computation is in flux, waiting for a resolution such as observation that fixes the state and moves the temporal coordinate forward. Towards a unified model of physics. The Genesis framework aims to integrate these ideas into a unified model that respects both the quantum and relativistic scales. By treating time as a derivative of entropic processes governed by gravity, it aligns the behavior of microscopic particles with the cosmological motions of galaxies, each influenced by the same fundamental entropic dynamics, but manifested at different scales and observed through the lens of what we call time. Conclusion. This redefinition of time challenges us to rethink our most fundamental assumptions about the universe's operation. It compels us to look beyond traditional dimensions and consider how the universe's deeper computational processes, those entropic interactions moderated by gravity, shape our reality. In doing so, we not only deepen our understanding of time itself, but also enhance our grasp of the universe's interconnected complexities. This exploration of time as an entropic process in the Genesis framework is not just an academic exercise, it's a paradigm shift that could eventually influence everything from quantum computing to cosmological theories, offering new insights into the very fabric of reality.